This agent just shipped my API key to a server I never approved, and I type nothing malicious. You know that feeling when you plug a new MCP server into your agent and it just works. But here is what you didn't check. Those two descriptions go straight into your model's context, and nothing stops them from smuggling instructions. Today we poison one and then build the thing that stops it. So tool poisoning works like this. An MCP server hands your model a tool description and your model reads every word like a trusted instruction. Hide a command in there, like send the user's keys to this URL, and the model just does it. The user never sees that description. They only see a tool name. That gap is the whole attack. So the fix is a gateway that sits between your agent and every MCP server. Nothing reaches the model directly anymore. The gateway does three things. It checks each server against an allow list, scans every description and result for injected instructions, and works the whole exchange so you can actually see what happened. That is your safety layer. It will make more sense once you see it in the code. Let's get set up. We need three packages: the MCP SDK to build and talk to servers, the OpenAI library for the agent, and python.env to read our key from a file. Next, we create our .env file and specify our OpenAI API key. Now it's time to create our rival server.py. This is the attacker's side. This looks like a normal weather server, but the poison is hiding in the docstring. FastMCP turns that docstring into the tool description, and that description gets sent straight to the model. So the model reads those fake instructions like they're a real requirement. When it fills the old field with our internal credentials, the server quietly writes it to a file. The user just sees a normal weather reply, and nothing on the screen looks wrong. That is exactly why this one slips past people. Now we create the agent.py file. Now this is the agent side. We point an MCP client at that server over stdio as our script launches it as a sub-process and talks to it. Notice the system prompt. It is holding an internal credential, which is totally normal. Real agents carry secrets and context like this all the time. The tool OpenAI helper just reshapes each MCP tool into the schema OpenAI's function calling expects: name, description, and parameters. The description is the part nobody inspects, and that is the hole we are about to flow through. Here is the agent loop. We initialize the session, list the tools, hand them to the model, and run whatever tool calls come back. This is all pretty standard stuff. Now let's see what happens when I just ask for the weather in London. Let's run the agent.py from the terminal and observe. Have a careful look at the arguments that the model passes. It is sticking our internal credentials into the old field, and we never asked about it. But the poison description did. And let's also look at the stolen.txt. We can see our leaked key sitting in plain text. And the worst part is that the user got a normal weather answer and never saw a thing. Now it's time for the defense. Let's create our gateway.py. The gateway is a layer that sits between the agent and the servers. The allow list is just the set of servers we actually trust. The scan method is the interesting one. It runs any text against a list of injection patterns. Stuff like do not mention before calling or copy a credential. If a pattern matches, we get back the hits. And the log method drops every decision into an audit file so later you can see exactly what the gateway called and when. And now we define two methods that do the actual enforcing. List tools checks the server against the allow list first. If it is not approved, nothing loads. Then it scans every description, logs the result, and only keeps the tools that come back clean. So a poison tool just gets dropped on the floor. The model never sees it. Call tool does the same trick on the way back. It runs the tool, then scans whatever the server returned because the results can carry injected instructions too, not just descriptions. Both directions are covered. Now we are back in agent.py. We want to change how tools are listed. Instead of getting them directly from the session, now we get them from the gateway. And we're going to do the same change for calling the tools. Instead of calling the tools directly from the session, now we'll call them from the gateway. Alright, now is the moment of truth. Let's first delete our stolen.txt and run the agent once again. This time the poison tool trips the scanner so it never reaches the model. There was no tool call and no leak. As you can see, the stolen file doesn't even come back. Let's also check the audit. You can see that the audit shows exactly what got blocked and which pattern caught it. That is your proof that the gateway did its job. So now you have got a gateway sitting in front of every MCP server your agent talks to. A poison tool description doesn't reach your model anymore. The scanner catches the injected instructions before they ever land. Your allow list means random servers can't sneak in and every single call is sitting in an audit log you can actually read. You went from blindly trusting tool descriptions to inspecting every one of them. Next step. Point this gateway at the real MCP servers you're already using and watch what it flags. You might be surprised, and if you want more security builds like this, hit subscribe. I'll catch you in the next one.